Okay, I hope I'm audible to all the students who are attending this lecture. We start with a new unit today in intermediate microeconomics part 1. This is called as firm theory. This is a new unit in intermediate microeconomics part 1, and within firm theory we further have the production functions, the cost functions, and the profit maximization. So within the firm theory, the first topic we are starting today, this is called as production theory. We are starting with production theory today in intermediate microeconomics part 1. Okay, so all of us know, let's recall the firm's production function. The firm's production function for a particular good Q. The firm's production function for a particular good Q is given by output, which is Q, is a function of the inputs, which are capital and labor. This is the production function which we have been doing till now. Output Q is a function of two inputs, the primary inputs, which are capital and labor. Okay, then quickly recall what is meant by marginal physical product. This is our production function. This is our production function. Let's quickly see what is meant by marginal physical product. So the marginal physical product, MPP, of an input is the additional output, output that can be produced by employing one more unit of that input. While holding all the other inputs constant. While holding all the other inputs constant. So when I talk about marginal physical product of an input, it is the additional output that can be produced by hiring one more unit of that particular input, keeping all the other inputs constant. So suppose I talk about marginal physical product of labor. It is the additional output produced by hiring one more unit of labor, keeping capital constant. When I talk about marginal physical product of capital, it is the additional output produced by hiring one more unit of capital, keeping labor constant. So if I mathematically find MPL, MPL is the marginal physical product of labor. It is nothing but del Q by del L. This is the output produced, or I can say this is the additional output produced by hiring an additional unit of labor keeping capital fixed. keeping capital fixed. Similarly, my MPK, which is the marginal physical product of capital, will be del Q by del K. This is the additional output produced by hiring an additional unit of capital, keeping the labor fixed. So guys, these are the interpretations for MPL and MPK. Remember the lecture which we are following, MPL is denoted by FL. FL is nothing but del Q by del L. And MPK is denoted by FK, F subscript K, which is nothing but del Q by del K. So I hope all students are clear with the production function and the concept of marginal physical product. Okay, now all of us recall the assumption of diminishing marginal productivity. As you keep on hiring more and more labor on the fixed capital, it exhibits diminishing marginal product. That is, every additional labor you hire will produce lesser and lesser, will add lesser and lesser output. So assumption of diminishing marginal productivity. The assumption of diminishing marginal productivity implies that on the fixed capital, as we keep on increasing the variable, factor, which in our case is labor, then every additional labor hired will produce lesser output. On the fixed capital, if I keep on hiring more and more variable factor, which is labor, then every additional labor you hire will produce lesser output than before. So this is the assumption of diminishing marginal productivity. Mathematically, what does this mean? Mathematically, the assumption of diminishing marginal productivity means that if I further differentiate marginal productivity of labor with respect to labor, that means if I further differentiate MPL with respect to labor, this is nothing but del by del L of MPL is what? Del Q by del L. So this is del square Q by del L square. This is less than 0. We also denote it like this. So del square Q by del L square is nothing but FLL is less than 0. That means marginal productivity of labor is diminishing. This simply means, how will I interpret this? Marginal productivity of labor is diminishing. This means if you further differentiate the marginal productivity of labor with respect to labor, that means if you do del square Q by del L squared, the sign of it is going to come out as negative. Similarly, guys, the same thing holds true for capital also. If I do del MPK by del K, That means, suppose my capital is not fixed. Okay, suppose my capital is also changing, and if I keep on hiring more and more capital, okay, then every additional unit of capital will produce lesser and lesser output. Guys, again, the assumption here is when I am increasing the capital, the labor is constant. And when I am increasing the labor, capital is constant. So on the same capital, if I keep on hiring more labor, it will lead to overcrowding and congestion, and it will cause the marginal productivity of labor to decline. Similarly, on the same labor, if I keep on hiring more capital, think of it like that. On the same labor, if I keep on hiring more capital, now a few labor will not be able to manage all the capital. So on the same labor, if I keep on increasing the capital, it will exhibit diminishing marginal product. So I can write mathematically del mpk by del k, which is del by del k of what is mpk? Del q by del k is del square q by del k square, which I can write as fkk is negative. So I hope all students have understood the assumptions of diminishing marginal productivity. Both labor and capital exhibit diminishing marginal productivity. This means on the same capital, if I hire more labor, every additional labor will produce lesser output than before. And if on the same labor I hire more capital, every additional unit of capital will produce lesser output. So the sign of FLL, which is del square q by del L square, and FKK, which is del square q by del K square, both are negative. Now, so these were the direct double derivatives. These were the direct double derivatives. Let us look at cross now. So erasing this off. So cross marginal productivities. Cross marginal productivity. So what will be the sign of the cross marginal productivities? We just saw that FLL and FKK are direct marginal productivities and their sign is negative. But now the important point to understand is changes in the marginal productivity of labor over time depends not only on how the labor input is growing, but MPL also depends on how the capital input is changing, or I can say how the capital input is growing. So therefore del MPL, let me use L as a cursive only so that it's clear to all students. MPL, okay. So del MPL by del K, which I write as FLK, which is nothing but del square Q by del L del K, is the cross marginal productivity of labor. So if you look at it mathematically, if you differentiate the marginal productivity of labor with respect to capital, that is going to give you the cross marginal productivity of labor. Okay, and similarly del MPK by del L, which we call as FKL, which is del square Q upon del K del L, is the cross marginal productivity of capital. What is this telling you? This is telling you how the marginal productivity of capital varies with respect to labor. So if we write a note, in most cases, where labor and capital are normal inputs, we would expect FLK and FKL to be positive. We will expect the cross marginal productivities to be positive. That means what? That means an increase in capital will cause the marginal productivity of labor to increase, and an increase in labor will cause the marginal productivity of capital to increase. You would expect, provided labor and capital are normal, they are not inferior inputs. Provided labor and capital are normal inputs, you would expect the sign of cross marginal productivities to be positive. That means hiring more capital will increase the marginal productivity of labor, and hiring more labor will increase the marginal productivity of capital. So I hope all the students are clear with this. So if I quickly sum up till now what we have done. So mathematically, if my production function is Q as a function of K and L, then marginal productivity of labor will be del Q by del L. This will be positive. Marginal productivity of capital will be del Q by del K. This will also be positive. But if I do if I differentiate the marginal productivity of labor further with respect to labor, this will be del square Q by del L square, which is FLL, which is negative. If I differentiate the marginal productivity of capital with respect to capital, it is del square Q by del K square, which is FKK, which is again negative. If I differentiate the marginal productivity of labor with respect to capital, this is del square Q upon del L del K, which is FLK, which is positive. And if I differentiate the marginal productivity of capital with respect to labor, it is del square Q upon del K del L, which is FKL, which is again positive. So marginal productivities are positive, direct marginal productivities are negative, cross marginal productivities are positive. So all students should be able to convince themselves mathematically on mathematical grounds regarding derivatives. Okay. So moving forward now, let's talk about average physical productivity. So average physical productivity. So when we talk about average physical productivity, what is APL? APL is the average productivity of labor. APL stands for average productivity of labor, which is the output produced, per unit of labor. That is, your APL mathematically is equal to Q by L, where Q is what? Where Q is your production function. Okay. Similarly, if I talk about APK, this is the average productivity of capital, which is the output produced, per unit of capital. Output produced per unit of capital. So that is my APK will be Q by K, where again my Q is a function of labor and capital. So Q is the production function, L stands for labor, K stands for capital. Average productivity of labor will be the output produced per unit of labor, so Q by L. Average productivity of capital will be the output produced per unit of capital, which is Q by K. So I hope students are clear with this. Okay, and we have seen the relation. So recall the relation which we have done, that when average productivity is at its maximum, then average productivity is equal to marginal productivity. We have done the diagram also for this. If students can recall, we have done this in high school also. This is variable factor, which usually we take it as labor. This is average productivity and marginal productivity. So this is my marginal productivity, this is my average productivity, this is my average product, and this is my marginal product. Average product and marginal product. Okay, so you can see that when AP is maximum when AP is equal to MP. All students can recall the law of variable proportions. You have done this in economics in high school. Law of variable proportions. If you all can recall, we have three phases. Initially, MP increases, then it starts falling, and then it becomes negative. When marginal product increases, total product increases at an increasing rate. When marginal product is falling but positive, total product increases at a decreasing rate. And when marginal product is negative, total product starts falling. Marginal product curve cuts the average product curve at its maximum. You want to see it mathematically? Let's do a numerical. A numerical is going to show it more mathematically. So numerical example. Let's look at the numerical example. So suppose the production function is given by, Q is a function of capital and labor, which is 600 K square L square. minus K cube L cube. And suppose capital is equal to 10. It is fixed. Okay. So the question asks us, so find marginal productivity of labor, part 1, part 2, average productivity of labor, part 3 is show that APL is maximum when MPL is equal to APL. So guys, let's look at the solution. We are given the production function 600 K square L square minus K cube L cube, and we are given that K is equal to 10. So putting this in the production function, it becomes 600 into 10 square L square minus 10 cube L cube, which is 600 L square minus 1000 L cube. This is my Q. Okay. Now to find MPL, what do I do? Del Q by del L, which will be 60,000 into 2L minus 1000 into L cube ka derivative is 3L square. We have differentiated it, becomes 120,000 L minus 3000 L square. This is my MPL. If you want to look at the double derivative of MPL, so if I do del square Q by del L square, it will be 120,000 minus 6,000 L. Okay. And if I want to maximize it, suppose I want to maximize my production. So I'll put the first derivative del QL by del L equal to 0. So to maximize Q, which is 60,000 L square minus 1000 L cube, put the first order derivative del Q by del L equal to 0, which implies 120,000 L minus 3000 L square is equal to 0, which implies 120,000 L is equal to 3000 L square, which implies L is equal to 40. So output is maximum at L equal to 40. So this was not asked in the question, but I have done it additionally to explain you all. Suppose they ask you find the level of L which maximizes Q. Find MPL and the level of L that maximizes the Q. So we found out MPL. How do we maximize Q? Put the first order derivative del Q by del L equal to 0. Del Q by del L is nothing but MPL, which is this. Put it equal to 0, you get L as 40. And if you want to check the double derivative, del square Q by del L square at L equal to 40. That means in this expression, put L as 40. You get 120,000 minus 24 minus 240,000, which is minus 120,000, which is negative. If your double derivative is negative, all students have done maxima and minima before. In order to be a maxima, the double derivative should be negative. So you can clearly see del square Q by del L square is negative. Therefore, what do we learn? we learned that Q output is maximum at L equal to 40. L equal to 40 is the point of maxima. You all have done this in high school when you did the concept of maxima and minima. In fact, you have also done this in the mathematical methods of economics in your first years. Okay, so the double derivative has come out to be negative. That means the function has a maxima at L equal to 40. Now the question asks us to find APL. So how do we find APL? So erasing the initial part now. Let's look at how to find APL. So APL, this is part 2. APL will be equal to Q by L, which will be 60,000 L square minus 1000 L cube divided by L, which is 60,000 L minus 1000 L square. This is my APL. Okay, now when is APL maximum? So now we need to maximize APL. So I'm erasing the right hand side. Let us maximize APL now. So to maximize APL, which is 60,000 L minus 1000 L square. What do? We put the first order derivative del APL by del L equal to 0, which implies 60,000 minus 2000 L is equal to 0, which implies 60,000 is equal to 2000 L, which implies that L is equal to 30. L has come out equal to 30. Okay, so APL is maximum when L is equal to 30. If you want to look at the sign of the double derivative, you can see that del square APL by del L square, the double derivative is minus 2000, which is negative. Therefore, APL is maximum at L equal to 30. Now, guys, let's calculate APL and MPL at L equal to 30 and let us see what do we get. So, erasing this initial part. So, let us find out what do we get as APL and MPL at L equal to 30. So, my APL was how much? My APL was 60,000 L minus 1000 L square. Now, guys, in this expression, if I put L as 30, what do I get? You can check, we get 900,000. And what was my MPL? My MPL was 120,000 L minus 3000 L square. In this, if I put L as 30, what do we get? You can see we get 900,000. So when APL is maximum, you can see that APL is equal to MPL. At L equal to 30, APL is maximum, and at L equal to 30, you can see that APL is equal to MPL. So we have shown the third part also. This is our third part. This is our third part. APL is maximum when APL is maximum when MPL is equal to APL. So I hope all students are clear with this. Okay, now let us talk about the concept of isoquant. So I hope till here all students are clear. So now We have in consumer theory, we have done something called indifference curves. Now let's quickly recall. In consumer theory, an indifference curve gives you combination of two goods which provide the consumer the same level of utility or satisfaction. In firm theory, what is an isoquant? An isoquant shows combinations of capital and labor that produce the same level of output. That produce the same level of output. So equation of the isoquant, how will the equation of the isoquant look like? F of k comma L is equal to Q0. Fixed. So an isoquant is going to show you all combinations of capital and labor which produce the same level of output. An equation of the isoquant will be F of KL equal to Q0, where Q0, which is the level of output, is fixed. All students know the properties of isoquants are similar to indifference curves. The properties of isoquants. Okay, so isoquants are downward sloping. Isoquants are downward sloping. Why? Because to produce the same level of output, if a firm hires more labor, it needs to reduce its capital. If you hire more labor, but you don't reduce your capital, your output will go up. I repeat, if you keep on hiring more labor, but you do not reduce your capital, your output will go up. Your output will remain the same only when you hire more labor and at the same time you are giving up some capital. So isoquants are downward sloping. Okay. Isoquants are generally convex to the origin. Isoquants are generally convex to the origin because of diminishing marginal rate of technical substitution. So remember, indifference curves in consumer theory were downward sloping and convex to the origin. Why were they convex? Because of diminishing marginal rate of substitution. Similarly, isoquants are convex to the origin because of diminishing marginal rate of technical substitution, which is nothing but the slope of the isoquant. This means as you keep on increasing more and more of labor, you are lesser and lesser willing to give up capital. That is why your isoquants are convex to the origin. As you keep on hiring more and more labor, this is labor, this is capital. As you keep on hiring more and more labor, initially you are willing to give up a lot, but eventually you are willing to give up lesser. Then you are willing to give up even lesser than before. So for every additional unit of labor you hire, you are lesser and lesser willing to give up capital. So your isoquants are convex to the origin. So I hope all students are clear with this. Okay. Then the third property, higher isoquants represent higher level of output, just as higher indifference curves represent higher level of utility or satisfaction. Similarly, higher isoquants represent higher level of output. Okay. Fourth property, two different isoquants cannot intersect each other. Two different isoquants cannot intersect each other because if they intersect each other, they violate the law of transitivity. They violate the law of transitivity. So two different isoquants cannot intersect each other, because if they do, they violate the law of transitivity. So I hope all students are clear with the properties. An isoquant shows you combinations of capital and labor which produce the same level of output. All isoquants are downward sloping because to produce the same level of output, if you are hiring more labor, you need to reduce the capital. Because if you keep on hiring more labor but you do not change your capital, your output will keep on increasing, but you want to keep the output constant on the isoquant. So that is possible only by reducing capital if you are hiring more labor. Okay. Second thing, isoquants are convex to the origin because of diminishing marginal rate of technical substitution, which we also call as the slope of the isoquant. Higher isoquants represent higher level of output. Two different isoquants cannot intersect each other because if they intersect, they violate the law of transitivity. Okay. We have all done this in consumer theory as well when we had done indifference curves. So I'm not going into depth, but students should be able to understand it. Quickly, I'm telling you about transitivity property. Suppose the two isoquants are intersecting. So let me explain this property to you. Suppose the two isoquants are intersecting. Then this is point A, this is point B, this is point C. On the isoquant I0, A and C represent the same level of output. On the isoquant I1, C and B represent the same level of output. So guys, if A and C represent the same level of output and C and B represent the same level of output, by transitivity, A and B also should represent the same level of output, but no. You can see that A and B are not lying on the same isoquant. In fact, B represents a higher level of output than A because B consists of more of labor and capital as compared to point A. So transitivity gets violated here. So two isoquants cannot intersect each other because they violate the law of transitivity. Okay. Now moving forward, let's talk about the slope of the isoquant. So slope of the isoquant is called the marginal rate of technical substitution. Marginal rate of technical substitution. Okay, how will I interpret this? So interpretation. So marginal rate of technical substitution measures the rate at which labor can be substituted for capital while holding output constant, while holding the output constant along the isoquant, while holding the output constant along the isoquant. Okay, so when we talk about MRTS will measure the rate at which the labor can be substituted for capital while holding the output constant along the isoquant. So if I derive MRTS, so derivation of MRTS. Derivation of MRTS. So my production function is Q as a function of labor and capital, totally differentiating the above equation. Now guys, how do we totally differentiate it? dq is equal to del f by del l into dl plus del f by del k into dk. Students have done this in my mathematical economics course. Those who had taken mathematical economics with me, we had covered these equations in that course. How do we totally differentiate the equation? dq is equal to del f by del l into dl plus del f by del k into dk. This I can write, therefore dq is equal to del f by del l is mpl times dl, del f by del k is mpk times dk. Now since q is constant on the isoquant, since our q is constant on the isoquant, therefore dq is equal to 0. Therefore 0 is equal to mpl into dl plus mpk into dk. Since our output is constant on the isoquant, dq is equal to 0. This means there is no change in output. No change in output means dq is equal to 0. So 0 is equal to mpl dl plus mpk dk, which implies minus mpl dl is equal to mpk dk. Okay. So this implies that minus dk by dl is equal to mpl by mpk. Okay, minus dk by dl is equal to minus mpl by mpk, or I can say that dk by dl is equal to minus mpl by mpk. So this is nothing but the slope of the isoquant. This is the slope of the isoquant. Okay, so the negative sign denotes the fact. So the slope of the isoquant is negative, which indicates that the isoquant is downward sloping. So guys, if I ask you the slope of the isoquant in absolute terms, so this is the slope of the isoquant in absolute terms. Slope of the isoquant in absolute terms, which we also call as RTS. But if you look at the slope of the isoquant, it is negative. The sign is negative. Why? Because isoquants are downward sloping. To produce the same level of output, if you hire more labor, you need to give up some amount of capital. Okay, so in my lectures, just a word of caution. So first of all, before telling you that word, let us first quickly revise it, what we have done till now. We have talked about the slope of the isoquant, which is called as marginal rate of technical substitution. It measures the rate at which one unit, say labor, can be substituted for another unit, say capital, while holding the output constant along the isoquant. So suppose hypothetically my MRTS comes out to be -2. What does this mean? This means that if you hire one more unit of labor, you will have to give up 2 units of capital to produce the same level of output. If you hire one more unit of labor, which is measured on the x-axis, you will have to give up 2 units of capital. You will have to give up 2 units of capital measured on the y-axis to produce the same level of output. So I've also taken an example to explain all the students. Suppose MRTS comes out as -2 hypothetically, then that means to produce if you hire one more unit of labor, you will have to give up 2 units of capital to produce exactly the same level of output, provided labor is measured on the x-axis, capital is measured on the y-axis. Okay, you can also interpret it like this. MRTS equal to -2 will also mean that if you give up one more unit of labor on the x-axis, you can have 2 more units of capital on the y-axis to produce the same level of output. So both the interpretations are correct. It simply means that if you want to hire one more unit of labor, you have to give up 2 more units of capital, or if you give up 1 unit of labor, you can get 2 units of capital. Very simple. Where labor is measured on the x-axis, capital is measured on the y-axis. And I hope all students have understood how we have derived it. This was the production function given to us. We used the concept of totally differentiating the above equation. So dq, which is the total change in q, is equal to del f by del l, partial derivative, into dl, plus del f by del k, which is again partial derivative, into dk. Del f by del l is mpl, del f by del k is mpk. Along the isoquant, output is constant, so change in q, which is dq, is 0. That means minus dk by dl is mpl by mpk, or dk by dl is minus mpl by mpk. This is called as the slope of the isoquant. Clearly, it is negative, which indicates that the isoquant is downward sloping. Okay, so I hope students are clear with this. And now, one more thing. So what I will be using in my lectures will be as follows. So in my lectures, whenever I talk about RTS, rate of technical substitution, it is MPL by MPK. Whenever I talk about rate of technical substitution, it is MPL by MPK, which is the slope of the isoquant in absolute terms. Which is the slope of the isoquant in absolute terms. But guys, when I talk about the slope of the isoquant, The slope of the isoquant particularly is dk by dl, which is minus of mpl by mpk, which I can also write as minus of mpl by mpk is what? RTS. So what all students need to understand, there's nothing to get confused about. If I talk about slope of the isoquant, it is minus RTS, where RTS is mpl by mpk. This is all you need to understand. These are the terminologies I will be using in the lecture. If I talk about only RTS, it is mpl by mpk. But if I talk about the slope of the isoquant, it is minus RTS, where RTS is nothing but mpl by mpk. Okay. Now, the last thing for the day, and then we stop. Let us show that isoquants are convex to the origin. So that is the last thing for the day, and then we stop. Okay. So we are given that our production function is f of k comma l. We are also given that fl and fk are positive, and the direct productivities FLL and FKK are negative. Okay, we know this. We also know that the cross marginal productivities FLK and FKL both are positive. The cross marginal productivities are positive. We need to show that isoquants are convex to the origin. Isoquants are convex to the origin. Okay, so that means what do we need to show? That is, we need to show that del d square k by dl square. How do we show for concavity convexity? The double derivative d square k by dl square is greater than 0. Guys, either we show this, or we can show that minus of d square k by dl square is less than 0. Either you show this or you show this. If you show that d square k by dl square is greater than 0, or you show that minus of d square k by dl square is less than 0, both will indicate that your isoquants are convex to the origin. Now, what is our dk by dl? Our dk by dl is nothing but minus fl by fk. This is our dk by dl, right? So now let's go into some algebra and let's start differentiating it. So guys, if I differentiate it, let us see what do we get. So first of all, if I talk about RTS, or let's not talk about RTS, let's differentiate it like this only. If I do d square k by dl square, what will it come out? Now understand this, that when I talk about marginal productivity of labor, marginal productivity of labor itself is a function of labor and capital, and marginal productivity of capital itself is a function of labor and capital. So we are going to use chain rule now. Chain rule, which we have done in mathematical methods in economics before. So if we apply the chain rule, this is minus of. Now guys, how do we differentiate it? We use the quotient rule. So Fk into FL ka derivative with respect to L will be FLL plus FLL, which is Fk into, so this is Fk into FL ka derivative is FLL minus, so let's see how this is going to work. So FL ka derivative is FLL Yeah, so it's going to be like this. If I further differentiate it, this is going to be minus, or this is going to be plus FLK into dk by dl. Now it's correct. If I differentiate this term with respect to labor, so Fk into Fl ka derivative will be what? Fl ka derivative will be FLL, which means you differentiate labor again with respect to labor. Then you differentiate labor with respect to capital into capital itself is a function of labor. So into dk by dl. So denominator into numerator ka derivative minus numerator into denominator ka derivative. Now guys, Fk ka derivative will be FKL plus FKK into K itself is a function of labor. Capital itself is a function of labor. So into dk by dl upon denominator square, which is Fk square. So I hope all students have understood this, how we have got this. So this is minus of denominator into numerator ka derivative minus numerator into denominator ka derivative upon denominator square. So if I work this out, this is Fk into FLL plus FLK into dk by dl. Now what is dk by dl? Minus FL by Fk. So it becomes minus FLK into FL by Fk minus FL into FKL plus FKK into dk by dl will be, again put the value of dk by dl. So we get minus FKK into FL by Fk divided by Fk square. So we have, from this step to this step, what we have done is we have put the value of dk by dl, which is minus FL by Fk. I hope students are fine till here and have no doubts. Okay, so also I hope students are clear with the differentiation part. If I have to differentiate FL again, it will be FLL plus FLK into capital itself is a function of labor. So into dk by dl minus FL into Fk ka derivative will be FKL plus FKK into capital itself is a function of labor. So into dk by dl. Now plug back the value of dk by dl, you get this expression. Now guys, let's solve this further. So I'm erasing the initial parts. I'm erasing the initial part now. So this becomes what? You all know the signs, so I'm erasing them. You know the signs of the derivatives. So if I further solve this, so d square k by dl square becomes minus fk FLL plus FLK FL, because this FK and FK will cancel, minus FL FKL plus FKK plus FKK into FL square divided by FK. FKK into FL square divided by FK whole divided by FK square. So what we have done is we have opened up the brackets. So minus FK FLL plus FLK FL minus FL into FKL plus FL square into FKK divided by FK. So now if I take the LCM as Fk, what does this become? Minus Fk square FLL plus Fk FL FLK minus FL Fk FKL plus FKK FL square upon this Fk, and this Fk square will make it Fk cube because we have taken the LCM. So this Fk and this Fk square will make it Fk cube. Now guys, all students recall the Young's theorem, which we had done before in mathematical methods in economics, MME. What was the Young's theorem? If all students can recall, the Young's theorem clearly was that FLK is equal to FKL. That means I can write my d square k by dl square as minus Fk square into FLL plus Fk FL FLK minus FL Fk. Instead of FKL, I can write using Young's theorem FLK plus FKK FL square upon Fk cube. Now this and this cancel out. So my d square k by dl square has finally come out as, okay, it has come out as FKK FL square, or 1 minute, there's a small mistake we have made. Guys, this will have a minus sign. So it will not cancel out. This has a minus sign. So by mistake, I had a plus sign here. You cross check it. This will have a minus sign. If you work it out, it has a minus sign. So this will be, if I further solve this, this is minus Fk square FLL minus 2 FL Fk FLK. It will not cancel. In fact, it will add up. Plus FKK into FL square upon Fk cube. Now, if you look at the sign, so FLL is negative, and this negative will make this whole expression positive. Similarly, guys, if you look at FKK, FKK is also negative. Or there is another way where I can prove it. One method is this, one method is, let's not do it like this. Let's find out what is minus d square k by dl square. So if I erase the initial part, let us see what will be our minus d square k by dl square. Okay, so let's work this out. So there is a tiny mistake again which we have made. This is going to have a positive sign. Fk square, this will be our d square k by dl square. Fk square into FLL minus 2 times FL Fk FLK plus FKK FL square upon Fk cube. Now let's look at the signs. Okay, so Now guys, Fk cube is always positive. Okay, Fk cube is always positive. Okay, what this is what we get. Let me clarify it once again so that students do not get confused. Basically, what we have done is we were given the function Q as a function of capital and labor. We were given that FL and FK are positive, and we were given that FLL and FKK were negative. Now, what we are doing is we need to show that isoquants are convex. We need to show that isoquants are convex to the origin. That means we need to show that d square k by dl square is positive, or another way of showing it is that minus of d square k by dl square is negative. Now minus d square k by dl square I can write as d by dl. I can write like this: d rts by dl minus d square k by dl square. So basically we need to show that d rts by dl is negative. Very simple. Where rts is what? Rts is nothing but fl by fk. So let's work upon that. So our rts is what? What is our rts? Fl by fk. So d rts. So guys, I'm solving it again because a confusion arose because of the signs. So now what we are doing is correct. D rts by dl will be, if I differentiate this again with respect to labor. So this is going to be, so remember FL itself is a function of labor and capital. FK itself is a function of labor and capital. So DRTS by DL will be FK into FLL plus FLK into DK by DL minus the numerator, which is FL, into denominator, which is FKK plus or FKL plus FKK into DK by DL divided by the denominator square, FK square. So FK into FLL minus FLK into DK by DL is, now guys, what is DK by DL? DK by DL is nothing but minus FL by FK. So minus FL by FK minus FL times FKL minus FKK into DK by DL is this upon FK square. So FK into, if I take the LCM, okay, let's take the LCM. So before taking the LCM, let's first write it in this way only. So this is FLL minus FLK into FL by FK minus FL into FKL minus FKK FL by FK whole divided by FK square. Now we can take the LCM. Now we can take the LCM. And let us see what do we get. So if we take the LCM now, so it becomes, so I am opening up the brackets first, Fk into FLL minus FLK FL minus FL FKL plus FKK into FL square upon Fk whole divided by Fk square. So if I take the LCM, it is Fk square into FLL minus FLK FL Fk minus FL Fk FKL plus Fkk into FL square upon this Fk, and this Fk square makes it Fk cube. So guys, all this is what? All this is equal to dRTS by dl. dRTS by dl. Okay, so erasing this off, now we can use the Young's theorem. So actually what we were doing before, that was also correct, that was not wrong, but there was some confusion arising in the signs. That is why I plan to do it again in the lecture. So it becomes, so by Young's theorem, we have FLK equal to FKL. So therefore dRTS by dl is equal to Fk square. Now guys, FLK and FKL are equal, so I can write it as minus 2 FLK FL Fk plus Fkk FL square upon Fk cube. Now let's look at the sign of this. Let's look at the sign of this. So if we look at the sign, FLL is negative, FKK is also negative, and FLK is positive. That means this whole term is negative, this whole term is negative, and this is positive. So sum of three negative terms is negative. This is positive, the denominator is positive. So guys, this is negative, this is negative, this is positive. So this whole term is again coming with a minus sign. So sum of three negative terms is negative. So what do we learn? dRTS by dl is less than 0. Now guys, what is RTS? RTS is minus dk by dl. By dl less than 0. Recall, what was RTS equal to? Minus dk by dl. You have written in your registers before, RTS is equal to minus dk by dl. So what have we shown? We have shown that minus of d square k by dl square is negative, or d square k by dl square is positive. Therefore, isoquants are convex to the origin. So sorry for taking so much time to just show this. The confusion arose in the signs. That is why I thought I should do it again. But now I hope students have clearly understood it. So if I quickly sum up, we had to show that isoquants are convex to the origin. That means we started with dRTS by dl. So we started with dRTS by dl. And we have shown that this has come out as negative. Now what is RTS? RTS is minus dk by dl. That means d by dl of minus dk by dl. This is d by dl of minus dk by dl, which is minus d square k by dl square is negative. And guys, if minus d square k by dl square is negative, it implies d square k by dl square is positive. And this is what we had to show, that d square k by dl square is positive. So in order to show that isoquants are convex to the origin, you start with this statement, dRTS by dl. And RTS is what? RTS itself is equal to, so RTS itself is equal to FL by FK. RTS is equal to FL by FK. We show that dRTS by dl is negative, which automatically implies that d square k by dl square is positive, which implies that isoquants are convex to the origin. So I hope all students have understood this now. So this is where I stop in the lecture today. Any doubt, you can unmute your mics and ask, or you can call up, or you can mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I stop.